In this tutorial, we will be covering a procedural trails technique that can be used for imitating wet maps and adding more visual interest to your animations. First of all, we have to create desired geometry that will be used as a collider body. We will start with a simple disk that will represent our ground surface. Increase its outer radius up to 400. Create the cube object and scale it down to 20 centimeters. Enable the fillet option and decrease its radius down to 3 centimeters. Next, we have to create multiple duplicates of this cube by using it as a child of the cloner object. Change its mode to grid and increase the number of clones. Navigate to Coordinates tab and change the settings to your liking. Now it's time to create another group of objects that will interact with this surface. For the sake of simplicity, we can use a simple sphere. Decrease the radius to 10 centimeters and the number of segments to 15. It is advisable to change its type to hexahedron that uses only quadrangles. This sphere will be subsequently deformed, so you have to disable the Render Perfect option in order to see its deformation in the final render. Next, we have to add another cloner object in order to create more copies of our sphere. Increase the number of objects and distribute these clones on the x-axis. Navigate to Coordinates tab and change the settings to your liking. Now we can randomize the position of these clones by utilizing Random Effector. It is advisable to organize your scene by grouping these objects and changing their names. Next, we have to turn our scene into dynamic geometry. Select the group of spheres. Navigate to Tags, Simulation Tags, and apply Soft Body. Increase the frictional value up to 50 so that the sphere objects do not fall down. Next, select the group of colliders. Navigate to Tags, Simulation Tags, and apply Collider Body. Change the Inherit Tag option to Compound Collision Shape in order to apply its influence to the hierarchy. In order to keep things simple, you can use the same value of the stiffness that we already applied to the soft body. It is time to increase the number of keyframes and cache the simulation in order to view the animation in real time. Right now, the simulation is cached successfully, and we have to colorize these collider bodies based on your sphere objects. The basic principles of this technique can be demonstrated by utilizing Plane Effector. Place this effector into the effectors field of the cloner object. As you can see, it changes the position of the clones. Turn off this option and define your desired color. Its effect will propagate across the entire surface. We have to define fall-off shape of the effector in order to restrict its effect only to certain objects. This task can be easily accomplished by utilizing Tracer Object. Drag the group of spheres into the Trace Link field and play the animation to trace their movement. Select the Plane Effector and place your Tracer Object into the Source Link field. This action determines that we will be using these splines as a fall-off source of the effector. Acceptable results will be achieved if you will increase the value of sample detail. This will prevent your animation from unnecessary flickering. Next, we have to match the value of sample distance with the size of our spheres. Let's press the play button to see the results in motion. Now it's time to go further and apply wet maps to our materials. Disable plane effector and apply the new material to the group of colliders. We have to retrieve information from our spline objects by utilizing Procedural shader. Place the tracer object into the objects field and activate edges and vertices in order to achieve the best-looking results. We will see its influence only during the rendering process. Decrease the end distance value in order to get an appropriate size. If you are not happy with the result, then you can change the value of intensity. We are able to remap these colors by utilizing Colorizer shader. We can either manually change the colors of the gradient or simply choose one of the presets from the large variety of predefined gradients. Let's render this animation to see the results in real time. In the final part of this lesson, we will examine how to optimize complex geometry in order to apply the procedural trails technique to its surface. First of all, we have to create a duplicate of this object in order to reduce its number of polygons and apply simulation tag to it. Create the polygon reduction generator and use it as a parent of the new geometry. We don't need to preserve 3D boundaries of this object, so you can disable this option. Next, decrease the number of triangles down to 1000 so you can use it with the soft body dynamics. This generator does not require more changes, and we are able to turn it into the polygonal mesh. Give an appropriate name to this object that will better describe its purpose. Select the low poly version of this object and navigate to Tags, Simulation Tags, and choose the soft body. Now we have to apply the motion of this dynamic geometry to the high poly version of the mesh. This task can be easily accomplished by utilizing the mesh deformer. Make the deformer child of the high poly object and drop the low poly version into the cage field. Change the external mode to the surface in order to prevent your geometry from visual artifacts and execute the initialize command. This specifies that we will be using the low poly object as a deformation source of the high poly model. Select the low poly model and change its position to your liking. Now you are able to cache the simulation in order to view the animation in real time. Finally, we have to trace its movement, but the low poly model has an unnecessary number of vertices. We are able to manually define the position and the number of its vertices by utilizing matrix generator. Change the mode to object and drop the low poly model into the object field. This action will create invisible points for render engine that are represented as the cubes in the viewport. Change distribution type to surface in order to manually define the number of created points and randomize their position by varying the seed value. We are able to use these points as the source of tracer object. Place the matrix generator into the trace link field and render the animation to see the final result of our simulation.